This video is for Chapter 1, Section 3, Exponential Functions. So these are mostly from Algebra 2. Exponential growth, exponential decay. So we're just looking at exponential functions. We're going to do the same thing we have been doing. We're going to talk about domain and range. And we're going to look at some exponential growth and some exponential decay problems. And hopefully some of this will be familiar to you. So this is the definition, which you can read. And under here I'm just going to write an example. So exponential functions look something like this. Your base is going to be a constant, and your variable is stuck up there as an exponent. That's why it's called an exponential function. So the exponent is your variable. Remember, f of x is the same as y, so this could also be written as 2 to the x. So the first one we're graphing is this one. So you want to think this is the 2 to the x function, so this is kind of like 2 to the x is the parent function. So it's multiplied by 3, so that's going to give it a vertical stretch, and then it's going to be shifted down 4 places. So I'm just going to do a little reminder sketch over here. Hopefully you can kind of picture 2 to the x. It's going to look something like this. It's going to be an exponential growth. This y-intercept is when x is 0, so 2 to the 0 power equals 1. So this point is over 0 up 1, so your y-intercept is 1. And it has a horizontal asymptote right here at y equals 0. So it's going to get closer and closer and closer to the y-axis. I'm sorry, the x-axis, but it's never going to cross it. So this graph is going to be similar, but we know it's going to be shifted down by 4. So I'm going to go down to -4, and I'm going to just kind of sketch in a dashed line here, because this is going to be my horizontal asymptote. Now you can put this in your graphing calculator to graph it, but you can also think of some of these things right off the bat. That would be your horizontal asymptote. When x is 0, so your y-intercept would be 3 times 2 to the 0 minus 4. 2 to the 0 is 1, so that would be 3 minus 1. So this would be -1. So your y-intercept is going to be right here at -1. So then you're going to approach this horizontal asymptote, but you're never going to cross it, and you're going to increase. Let's just see what happens when x is 1. So when x is 1, we're going to have 3 times 2 to the 1 minus 4. So that's going to be 6 minus 4. That's going to be 2. So this is going to be the point 1, 2. So if I put that in the wrong spot, when x is 1, y is 2. This was our y-intercept when x was 0. Y was -1. Let's just do when x is 2. When x is 2, I would have this. So it'd be 4 times 3, 12. 12 minus 4 is 8. So this is going to be over 2, up 1, 2, 3, 4, 5, 6, 7, 8. So you can see it's growing pretty quickly, which is what exponentials do, right? So even without the graphing calculator, you should be able to graph that pretty quickly. And then domain. So those are your x's. Well, it's going forever in this direction, and it's going up and to the right forever. So it can eventually take on every x value possible. So my domain is going to be from -infinity to infinity, or all real numbers, right? All real values of x. My range, you can see my y values are all above this line, which is y equals -4. So the smallest y value is -4, but I'm never equal to -4, so I do the parenthesis here. And then the y values continue to go up for infinity. So what is true here is y must be greater than -4. Okay, so that's just a little review of an exponential function. Here is another one. This one says, example 2, find the zeros. So zeros are x-intercepts. They're also called roots. They're also called solutions. Okay? Oh, we have solutions right in there. Of this function, graphically, sketch the picture as shown. So this is one you're probably going to want to do in your graphing calculator. So let's punch this in. Oh, look at that. I already have it in. Yay! So there it is, 1/3 to the x minus 4, and then I'm going to graph it. So it's going to look like that. It's a decay. As x increases, y is decreasing because this base number is between 0 and 1. It's a fraction less than 1, so that is exponential decay. Now remember, zeros are x-intercepts, so I want to find this x value. So that second trace, zeros, I want to choose menu item 2. Left bound, I want to get to the left of that point, so right there. So I want to say enter. Right bound, enter, enter. There's my 0. It says it's a 0. -1.2618. So the zeros are x equals -1.26, what was it? 2618. So you need to get into the habit now of at least 3 decimal places. 4 if you want to be safe. AP requires 3. So always, always, always at least 3. So you can round. This would be acceptable on the AP exam, 6 to 2. Or you can truncate. This would also be acceptable, 261. So you can round the 1 up to 2, or you can truncate. Okay, but has to have 3. I'm going to do domain and range. Oh, let me sketch this guy. So this is my x-intercept. And looks like down here at -3, so it's just a sketch. So I'm doing something like that. Maybe even not the greatest sketch. Make yours better. Domain for this is x is going to be all real numbers from -infinity to infinity, and range is going to be, this is shifted down 4 also, so y must be greater than -4. So from -4 to infinity is my range. Okay. This is a review of your rules of exponents. So these are the rules. These are from pre-algebra, algebra 1. These are some examples that I've written down to go with them. So I suggest you pause the video, and if you need these examples, put them in your notes. But the first rule is multiplying common bases. X times x, you add the exponents. 3 plus 4 is 7. And the next one I did here is this one. Exponent raised to another exponent, you multiply. X to the third raised to the fourth is x to the 3 times 4. When you're dividing, I always circle the bigger exponent first. That's where your answer goes. And then you subtract exponents. So you would have a 1 down here. 4 minus 3 is 1, so this would simplify to just x. This is the other case where you have more x's on the bottom. So in this case, your answer would be in the denominator. This is just power to a power within parentheses, so I did the power to the power first. 2 times 3 is 6, 2 times 5 is 10, then subtracted. 10 minus 6 is 4. More x's on the bottom, so the answer goes on the bottom. All right, I think I'm going to do one more example in this video, and then I'll put the rest in the next video. So this looks like it's a half-life problem. You did these problems in Algebra 2. Don't know if you remember. In Algebra 2, if you had it here at West Ottawa, we wrote it like this. A, 1/2, because it's a half-life problem, to the x over n. or y p to the 1/2 x over n. So they're just different ways of writing it. So the example 3, and you can read the definition here of half-life. Suppose the half-life of a certain radio substance is 20 days. So it takes 20 days for it to decay to half its original value. And that there are 5 grams present initially. So that's your initial amount. You're starting with 5 grams. When, so this means I'm solving for time, will there be 1 gram? So I'm starting with 5. I'm ending with 1 gram. And the question is, how long? How long is that going to take? So if you think about your formulas up here, this A, this P, these are all initial amounts, or what I'm starting with, and the Y is my ending amount. So for this problem, I'm ending with 1. They tell me what I'm ending with. They tell me I'm starting with 5. It's a half-life problem. And what am I solving for? Time. That's your x. Time is x in these problems. So this would be t over 20 because there's 20 days in 1 half-life. Okay, so this is solving an exponential. And you can tell because my variable is stuck up here in an exponent. So how did we solve exponentials in Algebra 2? Well, if it was a nice easy beginning problem, we got a common base. I don't think we can get a common base with this guy. So then what we did was we rewrote it as a log. But first you want to isolate this exponential all alone on one side of the equal sign. So what I want to do is divide both sides by the 5. So then I get 1/5 equals 1/2 to the t over 20. So you have to isolate that variable on one side of the equal sign, just like you always do, even though it's up in an exponent. So now I have variable all by itself. So now I want to rewrite it as a log. So this is going to be log base 1/2 of 1/5 equals t over 20. So log base 1/2 of 1/5 equals t over 20. There was some stuff in your summer work like this, so hopefully you remember that a little. Now all of this you can put in your calculator and then continue to solve for t. Now if you have a TI-84, it does any base you want. If you have a TI-83, you have to do that change of base formula where you do, I say the big one on top, not value. Well, this is how I do it. This looks like it's over that, so you do log of 1/5 over that equals t over 20. But once again, if you have an 84, you can put in any base you want, 84 or higher. What you get when you solve that for t is 46.439. And these are days. So story problem requires a story answer. Make sure that you include some units there. So 46.439 days. And I'm going to say, even though these are days, put the decimals in there. Just be safe, because you need to have 3 decimals for the AP test. This would probably, if you were rounding it, round to 46 days. Okay, I will finish these other 2, the rest of these examples in another video.